Here's a nice close-up of what we're going to be fixing in this video. This is a request to replace one of the pins in this bracelet that fell out. It's 14 karat gold. The pins are only about 0.5 millimeter tops in diameter. So this is a very dainty piece. It got snagged and it just didn't stand a chance. You see these flats between the bars? Those, I believe, were folded over the pin and then soldered in place. There's no undoing that without cutting into something. I tried to push the stuck pin out of this hinge with a sewing needle, but that didn't work. And so now we're going to mill it out at 0.3 millimeters to give us some leeway. And then I'll come in with a coping saw and cut out the space that I need for my new pin. So here's our replacement pin. It's made for 0.4 millimeter 3D printer nozzles. It's for shoving through and cleaning out any debris that might be stuck. I think it has a good combination of stiffness, stainlessness, and resistance to breaking when you bend it. There are better oils for this than CLP, but Tap Magic makes everything it touches smell like an oil refinery, so we're not going to do that. We're going in with a 0.9 millimeter bit, carbide 15,000 or so RPM, just to mill out some space for the modifications. This slot needs to have a more rectangular section. So we're going to come in again with a 0.3 millimeter bit to get rid of some of the fillet material and make our job easier later. This is looking familiar at this point, but here we have a close-up view of the slot we just carved out. After a little bit of touch-up work with an X-Acto knife, I'm gonna get a very sharp file in there too. Now I want to put a 0.5 millimeter hole in this 0.9 millimeter flat on the side of the bar. It's gonna be a little sketchy, just because I can't clamp any harder without breaking the bracelet further, I don't think. So there's gonna be quite a bit of wiggle. I've decided to use a 0.3 bit instead of 0.5 off the bat, and then I'm gonna widen it with a coping saw, just so that I have better tolerance here. I gave myself more space than the original design, hopefully so that I'll get better strength out of this. Because of that, I need to round the internal corner so that it doesn't impinge on itself when it gets wrapped around a wrist. So the bar needs to have 2.4-ish millimeters of this new spring inside of it. I think plus or minus a tenth would be fine, really. I can have some sticking out. and just cover it with solder. That's unfortunate. I didn't even look for it. I just cut my losses and made a new one. This is just regular electronic soldering paste. Probably too low temperature for this work. I tried to get a very reducing flame just to stop it from burning up quite as quickly. I'm skeptical of this 14 karat gold solder that Amazon sold me. I think I paid $20 for just a lead and tin. It was gold in the picture. We'll just buff it out when it's done. This little torch is running on butane and 8-gram nitrous oxide cylinders that are used nominally for whipped cream that you can buy on Amazon. It's really nice to not have to lug out a 40-pound oxygen tank and deal with refills and regulators. I'm blowing on this between cuts. I'm not burning myself. I thought since this flame was much more reducing than it needed to be and not balanced, my needle would not go noodle. I thought wrong, but that's okay. We're going to do all of our polishing with a 10,000 grit iron oxide jeweler's rouge. It's plenty aggressive enough for this metal, which is all buttery consistency, whatever the solder might be. And it's soft enough as a polishing compound to leave the sapphires alone. I used a water jet to blast out all of the waxy grit. Now I'll mail this back on Tuesday.